This is the fourth lecture in our series on differential equations. We're still reviewing topics to get ready to prepare ourselves for the meat of the course. And today we're going to graph parabolas. And mainly, we're graphing all quadratic equations. Equations of the form y is equal to ax squared plus bx plus c. So we're going to graph these and find the major points of locations about this graph. But in order to do that, what we're going to do is we're going to transform this into a different sort of function, so that tells us more about the function by looking at it than this does. This tells us the y-intercept. C is the y-intercept. But I want to know where the vertex of the parabola is, because if you remember, a quadratic equation is a parabola, and a parabola is shaped somewhat like this, and it has a vertex. And this form that we're going to use will tell us where that vertex is so that we can easily identify it. And it's not too difficult to transform this to the format that looks like this, which is y is equal to, a is going to stay the same, but we're going to have x minus h squared plus k. And hk is the vertex of the parabola. Okay. If a is positive, it's concave up. This is what concave up means. That means it's moving up. If a is negative, it's concave down, going down. So it has a maximum. And the maximum and the minimum is at this vertex. Okay, so how do we go from here to here? We use what's called complete the square. And complete the square is something that's going to be used outside the scope of graphing parabolas. So please pay attention to this. It's something that's going to come up over and over again, especially when we get into Laplace transforms in the future. Okay, so let's complete the square. So what do I mean by complete the square? Let's say I have x plus a squared. Okay, that's a perfect square binomial. And if I factor this out, or multiply it out, I'm sorry, that's equal to x plus a times x plus a, which is, now, I'm going to draw this so you can see it a little visual. Sometimes you'll see the visual a little better. This is a square. This is this square. And its length is x plus a, right? This length is x plus a, and it's a square, so that means this side is x plus a too. So that means we're going to have 4 rectangles in here, and you're going to see where they come from here. So this is x squared plus ax plus ax plus a squared, which is x squared plus 2ax plus a squared. Okay, and this is shown here because the area of this box is x times x, which is x squared. This side is a, and this side is x, so this is ax. And this side is a, and this side is x, so this is ax. And what's here? A times a. So you can see visually what this is. So when we complete the square, we're starting with the first 2 terms, and we're changing it into a format that's going to add a square. I know that's a minus, but that just means that the vertex is the opposite sign of this number if it's positive. Okay, so I want to change this. So what I'm adding here is half of this number squared, and it turns it into this format. And then what we add, we can take away. And I'll do this by example. So we're going to graph f of x is equal to x squared plus 4x plus 2. This is where we're going to start. So what we're going to do is complete the square. So we're going to take these first 2 terms here and turn it into a square, and then change this number so that it matches to what this number adds. So let's do that. So we add half of this number squared, and in doing so, it changes this to x plus half of 4 is 2 squared. So this number always becomes half of this number. But when we changed from x squared plus 4x to x plus 2 squared, we added 2 squared. So we have to take it away. Okay? Because if I FOIL this out, I get x squared plus 4x plus 4. But I want this to remain the same, so I have to take away 4. So whatever you square here, the square of this number, you have to take away. And now what does that become? That means that we have x plus 2 squared minus 2, because negative 4 plus 2 is negative 2. So we have a parabola. Let's go ahead and graph this guy out. The vertex is at negative 2, negative 2. So here's our vertex. The y-intercept is at x equals 2. Because if I plug in 0, 0 squared plus 4 times 0 is 0 plus 2. So that means it goes through 0, 2. And once I have one side, it's symmetric because it's a parabola. I have the other side. So here's our parabola. Here's our vertex. So let's discuss what we know about this graph. We know the vertex of the graph. Where am I going to put this? Let's put this right here. The vertex is at negative 2, negative 2. The axis of symmetry, where I fold this down, where I can draw and fold it over, goes through the vertex at the line x equals negative 2. So axis of symmetry. Through x equals negative 2. What about the domain? Well, parabolas. The parabolas can always be defined on all real numbers. So the domain is always negative infinity, comma infinity. But the range, well, that starts at the vertex, and if it's going concave up, it's a minimum. If it's going concave down, it's a maximum. So we start at negative 2, and it's equal to negative 2, because if I plug in x equals negative 2, this is negative 2 plus 2 is 0, then negative 2, right? So it's equal to negative 2, and it goes up to infinity. Okay. So let's look at another example and graph it as well. And the next one we're going to look at 2 more, just to see some examples of these. The next one we're going to look at is f of x is equal to 6x minus x squared minus 5. Okay, so this one's not really given in standard form either. But so let's kind of switch this around. So this is negative x squared plus 6x minus 5. Okay. So now you have to be very careful when we start with these first 2 terms to complete the square. So I'm going to factor this negative out. If I factor this negative out here, I factor it out of the second term as well. So this becomes minus 6x minus 5. Okay, now I want to show that again just so we can see that if I factor a negative out, I factor it out here too. Now, half of this number squared is 9, so I'm going to add 9. And then I'm going to add 9. Now, why did I add 9 when I added 9 here? Because there's a negative out here. So I'm really subtracting 9 and then adding 9. So be very careful with these signs. This is the part that really gets a lot of people. So this is going to be negative x. What did I square? I squared 3. Actually, I squared negative 3, but... And then negative 5 plus 4 is plus 4. Okay, so we have a parabola. It's concave down because this is negative. It tells us that means it's going downwards. And its vertex is at 3, 4. Okay, so let's graph this here. Let's see if I have room here. Alright. So 1, 2, 3. 1, 2, 3, 4. Okay. What's the y-intercept? The y-intercept is at x equals negative 5. This sign does not affect the y-intercept because if you plug in 0, negative 0 is still 0. So the y-intercept's at negative 5. So let's go down here. 1, 2, 3, 4, 5. So it's going to come down like this. And it's going to come down like that over here. And here's our axis of symmetry at x equals 3. Is x equals 3. Or the line of symmetry, whatever you want to call it. It's symmetric through this line. The domain, again, is negative infinity, all real numbers. We'll just put all real numbers. What about the range? Because we have a maximum, it starts at negative infinity, and then it goes up to 4, because that's where the y-coordinate is. It goes up to 4. It doesn't go up to 3, it goes up to 4. And that is a parabola. All right, we're going to do one more, just to really confuse you on completing the square, I suppose. But you need to practice this. This is important. 2x squared plus x minus 1. Okay. Let's see if I can not screw this up too bad. Okay. So we're going to factor a 2 out this time of the first two terms. So we're going to have 2 times x squared plus 1/2 x. And then I'm going to go ahead and then minus 1. Okay, so what are we squaring here? We're squaring half of 1/2. Half of 1/2 is 1/4, and 1/4 squared is 1/16. But I didn't add 1/16, I added 1/8. So we're going to take away 1/8. So now this becomes 2 times x minus 1/4 plus 1/4 squared, because I squared 1/4, right? Minus 9/8. Okay, so this tells us everything we need to know about the parabola. We got our y-intercept and we have our vertex. So the vertex is at negative 1/4, negative 9/8. So let's see if we can draw that over here. Let's see, negative 1/4. So those 2, 1, 2, negative 9/8. So it's about right there. Right, yeah, maybe right there. Close enough for government work. Okay, and then it goes through at y equals negative 1. So it's going to come up like this. And then it's going to come up like that. Beautiful parabola. Okay. So the vertex, the more important thing is that you can describe the function. The vertex, I already wrote, okay. The axis of symmetry is x equals negative 1/4. The domain is negative infinity, comma, infinity. But the range, where does it start at? It starts at negative 9/8, and it goes to infinity. Okay, so that is the review on parabolas. If you need some free tutoring, or not free tutoring, if you need some tutoring and you need some help or ask questions, you can ask in the comments or schedule some affordable tutoring on the Facebook page. I appreciate you watching, and we'll see you in the next video. Happy learning.